In today's class, we are going to go over motion under gravity. What do we mean by motion under gravity? Motion under gravity refers to the motion of an object being acted upon by the gravitational force of the earth. Do you understand? You know, motion talks about change in the position of an object with respect to time. Now, when an object is being acted, or a moving body is being acted by the force of gravity, gravitational force of the earth, we can say that that object is undergoing motion under gravity. Do you understand? Okay, please, there are some important concepts that I want you to know before we delve into any work example. When an object is thrown upward or released from a height, its motion is governed or affected by gravity. Please pay attention. Let's say we have a boy here. This boy is holding a ball. Now this boy threw this ball upward. Let's say we have this is the earth. Okay. Now if this boy threw this ball upward, this ball will come down. Why? Because the ball will be acted upon by the force of gravity. The gravitational force of the earth is what causes the ball to come down. Now, there are two instances. One part is that the ball was thrown up, you understand? The other part that having reached an height, the ball comes down. Now, when the ball was thrown up, it is moving against gravity, you understand? That means that the acceleration due to gravity G will be what? Negative. Do you understand? Please, it is very important that you understand this concept right now before we delve into any work example. That's why I need you to pay attention. Now, let's say we have a boy holding a ball. Imagine it now. Now, this boy throws the ball up. The ball gets to this height and it falls down. You understand? When the ball is going up, it is moving against gravity. You understand? That means that the acceleration due to gravity will be equals to negative. You understand? The acceleration due to gravity will be negative. You understand? Now, when the ball is coming down, the acceleration due to gravity will be positive. The reason is because the ball is moving towards gravity. You understand? In the first case, the acceleration due to gravity is negative because the ball is acting against gravity. It's opposing gravity. You understand? Because the gravity is the force that causes an object that is at an height to come down. You understand? So when the ball is thrown upward, its motion is opposite to the direction of gravitational pull of the earth. You understand? And when it's coming down, its motion is in the same direction as the gravitational force of attraction of the earth. You understand? So that is one of the basic concepts. Are you paying attention? Now, don't forget, in our previous class we learned equation of motion. You see, this concept is related to equation of motion. You understand? The equation of motion under gravity is derived from the equation of motion for rectilinear acceleration. You understand? Please pay attention. You know, equation of motion under rectilinear motion is this. The first one is V equals to U plus AT. You understand? The second one is S is equals to UT plus 1 over 2 AT squared. Okay? And the third one is V squared equals to U squared plus 2AS. This one is rectilinear motion. Okay? Now, for equation of motion under gravity, you see there are two things that you have to pay attention to. The first is that when a body is thrown upward, are you paying attention? When the body is thrown upward, the equation becomes like this. Please pay attention. When the body is thrown upward, let me put it like that. V equals to U plus. Now, because the body is being thrown upward, for example, like looking at the previous example that we did, look, the ball is being thrown upward. The acceleration due to gravity becomes negative. So, instead of A, please pay attention. For motion under gravity, A equals to G. Are you paying attention? A equals to G and H and S equals to H. When we are dealing with equation of motion under rectilinear acceleration, we have A, we have an S. You understand? But when we are dealing with equation of gravitational acceleration, the A we change to g. You understand? I'm just telling you the parameters that changes. You understand? You know, I told you equation of motion under gravitational acceleration is derived from the equation of motion undergoing rectilinear acceleration, and the equation of motion undergoing rectilinear acceleration is this. You understand? Now there are two parameters that changes. The first parameter is the a. In equation of gravitational acceleration, motion under gravitational acceleration, the a equals to g. You understand? You know, and the second one is s. S is distance. The s equals to h when we are dealing with motion under gravity. Do you understand? So now, because the a equals to g and the body is moving upward, the acceleration due to gravity g will be equal to what? Negative. So I'm going to have negative gt. Do you understand? This is what I'm trying to explain. Okay? Do you know the reason why we have the negative sign? Because the body is moving opposite to the gravitational force of the head. You understand? Because it's opposing gravity. So the g is what? Negative. Now, for the second part, which is what? S. In this case, we are going to have h. The reason why we replace s as h is because we are dealing with height. You understand? We are dealing with height. Motion under gravity deals with height. So height equals to u t plus, okay, now it will be negative, minus 1 over 2 gt squared. Okay, and the last one, which is the last equation, will be v squared equals to u squared minus 2gh. Do you understand? You can see that there are two parameters that changes. The first parameter is that a equals to g and s equals to h. That is why I want you to be consistent. You understand? If you pay attention to our previous class on uniformly accelerated motion, equation of uniformly accelerated motion, you will see that we talked about this. We learned how to derive this. But now we are dealing with motion under gravity. Motion under gravity deals with height. You understand? And the gravity is what changes the equation. Because when we talk about gravity, we can have a body opposing gravity or a body moving towards gravity. You understand? A body moving along the moving in the direction of the force of gravity. Now, because we are dealing with an upward motion now under gravity, upward motion under gravity. For example, when the ball is being thrown up, I told you that the gravitational acceleration will be equal to what? Negative. And that is why we have negative, negative, negative. Do you understand? Okay? Now, when the body is moving downward motion, okay, downward motion, the acceleration due to gravity will be what? Positive. Do you understand? Acceleration due to gravity will be positive. So I'm going to have v equals to u plus gt. You understand? And the second equation will become h equals to ut plus 1 over 2 gt squared. And the third equation will become v squared equals to u squared plus 2gh. Do you understand? So you can see now, this is I just explained the condition under motion under gravity. This equation is used, this theory equation is used when we are dealing with object that is moving upward, that is opposing the force of gravity. Are you paying attention? Now, this equation, which is the second one, is used when we are dealing with motion of an object moving in the direction of the force of gravity. You understand? For example, look at this ball. This boy was holding this ball, then throw it upward. The acceleration due to gravity is negative here. Immediately the ball gets to this height. It gets an height. When it gets to this height, it comes down. The acceleration due to gravity becomes what? Positive. You understand? That is why, because the ball is falling downward, is moving downward, moving towards the force of gravity of the earth. Okay? So that is the two case. Just to understand. Now let us proceed. There is another important 3 points that I want you to note. Okay? When an object is thrown upwards, its final velocity at the highest point is what? 0. Please pay attention again. Let's go back to this example. When an object is thrown upward, when this boy throws this ball upward, the final velocity of the ball at this point is equals to 0. V here is equals to 0. And I will explain the reason. The reason is because velocity causes an object to change position. You understand? Now, when the velocity got to this point, the object can no longer move upward because the velocity has decreased to its barest minimum. It cannot move upward again. So it begins to what? Come down. You understand? So at this point, the V equals to what? 0. Please pay attention. It's simple. How you have to understand is just what I'm just trying to explain the basic concept so that when we start the calculation, you'll be able to understand. Okay? When this ball was thrown upward by this boy, it got to this point. This is the peak which the ball reached before coming down. The velocity at this peak is what we call V equals to 0. You understand? Okay? Let's look at the second point. The second point is that when an object falls downward or is released from a height, its initial velocity u equals to 0. Okay, now look at this. Okay, let's say we have another diagram in this place. We have a boy standing on a fence. You understand? This boy is holding a ball. Now, if this ball is released, the initial velocity of the ball u equals to 0. Do you understand? Let me explain the reason. The reason is because the ball is being held before. You understand? Now, because we are dealing with motion under gravity, the initial velocity of the ball is equals to 0. And the reason is because the ball is falling downward. You understand? So when an object is released or falls downward, the initial velocity of that object is equals to what? 0. So that is the second condition. The third condition is that the time it takes for an object to travel upward is the same time it takes to come down. Do you understand? The time it takes for an object. Okay, let's go back to the first example now. The time it takes for this object to reach this height is the same time it takes for this object, which is the ball, to come down. You understand? Those are the 3 points that you have to note. The first point is that when an object is thrown upward, the velocity at the peak, that is the velocity at the maximum height, is equals to 0. You understand? So now, the second point is that when a body is released from an height, you understand? When a body is released from an height, for example, this boy is holding this ball. This ball is released from this height. The initial velocity of this ball is equals to 0. And the third point is that the time it takes an object to travel upwards is the same time it takes to come down. Do you understand? So that is the 3 points. Now, okay, let's look at the application of what we have learned so far. Let's start with the first question. A ball is released from a height above the ground. Find its velocity after 5 seconds. Take g equals to 10 meters per second squared. Okay? Please, I want you to pay attention. A ball is released. Pay attention. A ball is released from an height above the ground. Let's say this is the height above the ground. This is the ground level. Okay? This is the ground level. And this is the height above the ground. Let's say this is the ball. This ball is released from this height. You understand? This ball is released from this height. Now, we are asked to find its velocity after 5 seconds. That means that t equals to what? 5 seconds. Okay? And g equals to what? 10 meters per second squared. Acceleration due to gravity is what we call g. You understand? Acceleration due to gravity is what we call g. Okay? Now, how do we calculate the velocity of this object? Now, based on what you have learned so far, you know that when I told you that when an object is coming downward, please pay attention. When an object is traveling downward, what sign will the acceleration due to gravity be takes? What will be the signs of the acceleration due to gravity? Will it be positive or negative? It will be positive. The reason is because the body is traveling downward. You understand? It's moving from this height towards the force of gravity. That means that the sign which the acceleration due to gravity will take will be what? Positive. You understand? Now, the ball is released from this height. So g will be what? Positive. Are you paying attention? Another important statement to pay attention to in that question is that we are told that the ball is released from an height. You understand? Okay, the ball is released from an height. That means the ball forms from an height. And I told you, I gave you 3 points. If a body is thrown upward, if an object is thrown upward, the velocity that it reaches before coming down is what? 0. Are you paying attention? Now, when a body is released from an height, the initial velocity of that body will be what? 0. Now, the ball that is thrown upward, when it got to a peak, it comes down. That velocity that we're talking about here is what? Final velocity. You understand? But when I hold, for example, let's say I hold this marker now and I release it, the velocity of that body when I hold the marker, when the marker is being held in my hand, is 0. You understand? The velocity, which is the initial velocity, when the marker is still in my hand, that velocity is what? 0, because the marker is not moving. You understand? So because the ball is being released from this height, this means that the initial velocity of that body will be what? 0. That means I'm going to have u equals what? 0. Do you understand? Now we can easily determine the final velocity after 5 seconds. We are going to use the downward equation of motion under gravity. You understand? We are going to use one of these equations. Now, how do you identify the one that you are going to use? You are going to check the parameters that you have here and look at the equation that suited the parameters. You understand? Pay attention. Having known that because the body is traveling downward, you are going to use any of these equations. You are going to use one of these equations rather. You understand? Now, how do we identify the equation that we are going to use? Look at this parameter. Look at this equation. Which of these parameters suited this equation? Okay, which of these equations suited this parameter? It is the first equation. We are going to use this. The reason is because we are looking for velocity. We've been given the what? The initial velocity. We've been given the acceleration due to gravity as what? 10 meters per second squared. And t is what? 5 seconds. You can see now. So the first equation is, we are going to go with the first equation. So the first equation is what? V equals to u plus gt. V, which is the final velocity that we are looking for, equals to u. U is what? 0 plus gt. G is what? 10. 10 multiplied by time. T is what? 5. So V equals to what? 0 plus 50. So V equals to 50 meter per second. Hence, the final velocity of the object, the final velocity of the ball after 5 seconds is what? 50 meter per second. Do you understand? Okay, let's look at the second question. At exactly 2 hours, 0 minutes, 0 seconds, a pendulum bulb is thrown vertically upwards from the ground with an initial velocity of 75 meters per second. At what time will the bulb return to the ground? Take G equals to 10 meters per second squared. To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link. Or you should check the playlist on this channel. Okay, see you in the next class.